grade 11s. It is a Maths Monday, and today I'm with Indy and Natasha. We're doing number patterns. So guys, don't forget to talk to us on facebook.com/learnextra. Tweet us, guys, because Tweet has been so quiet lately. Just
Too
tweet
quiet.
us. Too quiet, hey?
Too quiet.
Tweet us, guys, at Learn Extra, and we will be interacting with you guys, talking to you guys. Comment on our Facebook, wall post, guys. Anything that you want to do, we will cater to you, as Natasha is here to do that. So we'll just carry on with the show and enjoy it, guys. Over to you, Natasha.
Thank you so much, guys, and it's fantastic to be here for the grade 11 show. Once again, guys, going over number patterns, carrying on from last week. Remember, we did number patterns 1, where we just looked at a basic introduction of quadratic sequences. We looked at how you identify a quadratic sequence, and we did a few examples. So this week, we're going to look at what a lot of you guys were asking us questions on the Facebook page last week about. We're going to look at some of those kind of questions. Okay, specifically, we're going to look at using the general term of a quadratic sequence to find the value of n. Okay, so we're going to use the general term. It's going to be given to us, and that's going to help us to find the value of n. And the other thing we're going to do is to find the general term of a quadratic sequence. All right, so let's look at some of the key concepts, and especially just going over finding the value of n in quadratic sequences. Very, very important, guys. N is a positive integer. Okay? Now, hopefully you guys remember what an integer is. An integer, maybe I should ask the two ladies on that side. No, they've got a look of terror on their faces, so we're not going to do that. Okay, an integer
is a number.
It's a negative number.
It's a
Negative number.
All right. Well, it's a positive,
It's a positive
and
and a
negative number,
negative.
but very, very importantly, an integer is a whole number. In other words, it's not going to be a fraction. Okay, so
or a decimal
hopefully-
component.
Exactly. So hopefully you guys at home know that. An integer, you're looking at positive or negative numbers, and we're talking about whole numbers. We're not talking about fractions, so we're not talking about 1 1/2 and that kind of thing, or decimals, as Indy said. But when we're looking at integers in the context of finding n in the general term or in the quadratic sequence or whatever sequence you're given, when you find n, it has to be a positive integer. Very, very important. We're only looking at positive whole number values. Okay, we often call these integral values. Positive integral values. All right, so to kick things off, we're going to start with an example. We are given that Tn is equal to 3n squared plus 2n plus 1. The first question says, find term 100. So guys, this is a little bit of revision. We did something similar last week. If you asked to find term 100, remember the n in Tn is a placeholder. So the n we can replace with any term that we are looking for. So therefore, if I'm asked to find term 100, all I'm going to do is replace n with the value 100. So term 100 in this quadratic formula is going to be 3 times 100 squared plus 2 times 100 plus 1. Okay, so we're going to call up our calculator and let's see what that gives us. So we've got 3, and in brackets we've got 100 squared plus 2 times 100, close brackets, plus 1. And that gives us an answer of 30,201. All right, so that is the value of the 100th term. Okay, so remember, all we did when they asked us to find term 100 is we replaced n with 100 in the quadratic sequence formula that they gave you. Remember from last week, to identify a quadratic sequence, if you are given a list of numbers and you need to check if it's a quadratic sequence, there needs to be a constant second difference. If you are given the formula, then you need to make sure you've got a square. Okay, so an n squared in this case tells us that we are dealing with a quadratic sequence. All right. Okay, so the next one. And this is really key. We're looking for which term in the sequence has a value of 57. Okay, which term has a value of 57. Now, very importantly, guys, what does this 57 represent? Now, often people get confused between making the whole Tn, for example, equal to 57, or replacing the n in this quadratic sequence with the value of 57. So hopefully you guys at home realize what this question's asking us to find. They want to know which term has a value of 57. So in other words, they're looking for n. Okay, that's what we're looking for here. Don't make the mistake of saying n is 57. Okay, so we're looking for n. Remember, n is just a placeholder. We don't know which term in what position has a value of 57. So we want to find out which position term has a value of 57. So in other words, we've got our sequence of numbers. Somewhere in the sequence, one of the terms is 57. We need to find out where that term sits. Okay, so in other words, Tn is equal to 57 and we're solving for n. So we simply look at our formula, 3n squared plus 2n plus 1. We're going to use that formula. That, remember, gives us Tn, but Tn in this case is equal to 57. So I simply equate that to 57. And then we're going to simplify and factorize this. Okay, so we get 3n squared plus 2n plus 1 minus 57. Remember, when we take the 57 over to the left-hand side, we need to change its sign. So it's going to be 1 minus 57, which is going to give me minus 56. Okay? You guys recognize that is now a quadratic equation. I need to factorize that into its two factors. All right, and the factors here, we're going to have 3n and n. 56 is 14 times 4. And we need to have a positive 2n as the middle term, so it's going to be 3n plus 14 times n minus 4. Okay, remember, like a normal quadratic equation, we're going to let each bracket equal to 0 in order to solve for our variable. So if 3n plus 14 is equal to 0, we get n is equal to minus 14 over 3. Now we have a problem because we said n has to be a positive whole number. N has to be a positive integer. So therefore, we can't accept negative 14 over 3 for two reasons. It's negative and it's fractional. So this is definitely going to be not applicable. Okay, you can't have negative 14 over 3 terms. So therefore, our answer is n is equal to 4. So guys, what this tells us is that term 4 in this quadratic sequence has a value of 57. That's basically what it's telling you. Okay, now remember, the whole thing about n can't be negative. The reason for that, if you think about it logically, remember, we're dealing with sequences and terms and those kinds of things, and we're counting things. So if, for example, this question said, how many pupils in your grade 11 class? It's not possible for you to have negative 20.5 pupils. Okay, we're counting a number of things. So in a similar way, you can never ever have n as a negative fraction because it's a counting number of things. So therefore, n has to be positive number. I think I've drilled that point over and over again. You'll be amazed how many people still get to a test and make that mistake of putting n as -2 or -3 or whatever the case is. So it's also a check for you. If you're getting only one answer and it happens to be a negative or a fractional answer, you know that you've made a mistake if you're dealing with sequences in that. Okay, I'm going to cross over to the ladies and see if we need to take a break or if we can carry on.
Well, guys, thank you very much for all your responses on Facebook. You guys have been giving us positive feedback and actually enjoying the show, so we will continue on with the show. So over to you.
Well, Given has said, she is a great teacher. See, this is Natasha. Let's make her blush a little bit. She is a great teacher, and I'm in grade 10, and I'm just participating. I love the show. You rock. On that note, big up to Macmillan. Thank you guys so much for sponsoring this show. You guys are awesome. Why don't you read another one? Here, look at all these great.
Awesome. Grade 11 maths time. That's Tiamo Joseph Sibopela. Thank you very much, Tiamo. We're glad that we can help you and that you're actually enjoying the show.
So now we're not going to take a break. We're going to send it right back to Natasha after that mini little insert. While I'm here, follow us on Facebook, facebook.com/learnextra. Natasha, take it away.
All right, so I must remember never to give them a little interlude like that.
Never again. You'll never do it again.
But anyway, guys, I'm so glad that you guys are enjoying the show, and I hope that you understand. For the first example that we are going to do on finding the general term of a quadratic sequence, I'm going to do it in a lot of detail, and I'm going to go very, very slowly. So if you are lost at any point, please send your queries through to our Facebook page. Okay, so let's get started with this one. All right, so just going over, remember that Tn is equal to an squared plus bn plus c is the general term for a quadratic sequence. All right, when we say general term, it's almost like saying we're finding the formula for the quadratic sequence, if you want to put it that way. Just a reminder, a quadratic sequence is a sequence of numbers in which the second difference between the consecutive terms is constant. All right, and we call that second difference a common second difference. All right, so let's just remind you about that second difference. We did this in detail last week, but let's have a look at our first example. If I look, I'm going from 4 to 9, 16, and then 25. The question says find the general term of the sequence. Remember, if you're given a question like this, you don't know if it's quadratic. You don't know. You can't tell just, well, this is actually an easy example, so you actually could tell just by looking at it. But generally, you can't tell if it's quadratic. The first thing you need to do is to look for your common second difference. So let's have a look. So the first thing we do is find the first difference by saying term 2 minus term 1, so 9 minus 4 gives me 5. Then I say term 3 minus term 2, 16 minus 9 gives me 7. And then I say term 4 minus term 3, 25 minus 16 is 9. All right, so that's the first difference. Okay, we need the second difference, and remember, if the second difference is constant, then we have a quadratic sequence. So if I say 7 minus 5, I get 2, and then 9 minus 7, I also get 2. So we have success. We have a constant second difference. Therefore, we know, yes, it is quadratic. So that means that our general term is going to look something like this. Let's just get rid of that. Tn is equal to an squared plus bn plus c. So it's going to look something like that. Guys, the values for b and c could be 0. Okay, so you might just have a case where you have Tn is equal to an squared. But as long as you've got the square, tells you it's quadratic. All right, let's carry on. So we've got our constant difference is 2. We asked to find the general term. That means we need a B, and C. Now, there is a way that you can show that your A, which is the coefficient of n squared, is equal to the second difference divided by 2. There is a way to show this. I'm not going to go into details on how you show this, okay? We're just going to accept that to find A, which is the coefficient of n squared, it is your second difference divided by 2, all right? So if I want A for this sequence of terms, I'm going to say my second difference, which is 2, divided by 2, and I get 1. So therefore my formula now becomes Tn is equal to, now remember A has a value of 1, so this is going to become 1n squared plus Bn plus C. Okay, 1 times n squared is obviously just n squared. We need to find B and C, and in order to do that, we've got to use simultaneous equations. Guys, I don't want to get into the rest of this just yet because I know that we're about due for a break and this is quite long. So what I want you to do is, if you have forgotten how to do simultaneous equations, quickly go to your textbook, page through, and have a look and see how you should do simultaneous equations. We're going to use the method of substitution to help us find the values for B and C in this specific quadratic sequence. But what you also need to remember is how to do substitution, and just try and remember this example. I'll go over it again briefly when we get back from the break, but I'm sure it is almost time for us to have a quick break.
Definitely, definitely.
Okay, guys, while we go to a break, I just want to read at Subs of 53. He says, thanks for today's lesson, guys. Really appreciate it. And at Alfred Lebohang says, at Learn Extra, keep on doing the good job, guys. We are learning a lot. Guys, we appreciate tweets like this, and we also want your comments on Facebook. Don't forget to follow us on Twitter. It's at Learn Extra. And on Facebook, it's facebook.com/Learn Extra. So, guys, please just hit us up. Talk to us, interact with us. We are here for you. So we'll be back right after this, so don't you go anywhere. Welcome back, guys. After that very short break, we are back with maths. We're doing number patterns with Natasha. But just to inform you a bit, we've got our random acts of kindness thing going on. So if you do go onto our events page onto Facebook, you'll see all the information. You post your photos, you tell us what act of kindness you've actually done, and then you stand a chance to win one of these great prizes.
All of these amazing chips.
Of these, you get chips for the whole nation. You get
Thank you,
a
Simba, for
t-shirt.
donating
Thank
those.
you so much, Simba. I didn't even know they make Cheetos anymore, but you get Cheetos.
I love Cheetos.
You get a t-shirt, you get a mindset lanyard, you get CDs, guys, you get Kayam Tetwa, Unati, so many people. But we've also got to tell you about this World Education Games, guys. So Indy's going to tell us more about that.
This is so awesome, guys. It is happening from the 5th to the 7th of March. You need to register before the 28th of February. I think it says there. And what it is, it's worldwide. It's done online, and you can participate in this amazing event by going to www.worldeducationgames.com. I will post this onto our Facebook page, and let us know. You know what, Looney, there's quite a few people on the page that have said to us they've already registered, their class is going, and they're all taking part. So if you are one of those guys, please post on our Facebook page and let us know. I think Rob told us in the last one, I think there were like 3 million people worldwide. 4 million worldwide taking place in this amazing event.
So just encourage all your classmates, guys, your teachers.
Tell your teachers.
Be in on this World Education Games. It's quite good. So just get in on it, and we will post information about it. So just stay tuned, and back to you, Natasha.
All right, great. Thank you, guys. So I hope that you've had a quick little break and a quick little revision of simultaneous equations. Quickly, we're going to go over the example I started with and get into the crux of it, which was finding the general term. Okay, so the question was find the general term of the sequence 4, 9, 16, 25. I showed you that that is a quadratic sequence because we had a constant second difference. I also showed you that A was equal to the second difference divided by 2. So we found that A had a value of 1. We then plugged that value of 1 into our general term, and we need to now find B and C, and we're going to do that using simultaneous equations. Guys, there are lots of other ways to find B and C. The reason I use simultaneous equations is because it's the one that everyone remembers the best. Okay, so yes, there are other ways, but simultaneous equations, foolproof, no formulae or anything like that to remember. Now, I need to do a simultaneous or set up a simultaneous equations so I can solve for B and C. In order to do that, I use the terms that I've been given in the sequence. You can use any of these terms, okay? I'm going to use T2, remember that's term 2, and term 2 in the second position, we see that that is 9. So term 2 is equal to 9 and term 3 is equal to 16. So those are the two I'm going to use to help us find B and C. So to set up the first equation, I say, well, remember n is a placeholder, so I know that term 2 has a value of 9. So I'm going to simply say term 2 is equal to, and replace all my n's with 2. So it's going to be plus b times 2 plus c, and make that equal to 9. Okay, that's going to give us one equation. Let's simplify it a little bit. So I'm going to get 4 plus 2b plus c is equal to 9. We can simplify that a little bit more by taking the 4 over to the right-hand side. And I get 2b plus c is equal to 9 minus 4. If we take it over, remember to change your sign. So it's going to become 9 minus 4, which is 5. Okay? In this, I can see that I can make c the subject of the formula. In other words, isolate the c, so we set this up for our simultaneous equation, because then we can use the method of substitution, which you learned in grade 10. So I can say c is equal to 5 minus 2b, and I'll call that equation 1. All right? So this is just a little bit of revision on simultaneous equations from grade 10. All right, so term 3, we're going to do the same thing. We know that term 3 has a value of 16. So in place of n, I'm going to put 3 in this case. So it's going to be 3 squared plus, and remember guys, just in case it's cut off and you can't see, the formula we're using is this one. So we're going to have term 3 is equal to 3 squared plus 3 times b plus c, and that's equal to 16. Okay, from this I'm going to get another equation, 9 plus 3b plus c is equal to 16. So 3b plus c is equal to 16 minus 9, which is 7. We call that equation 2. And hopefully this is all ringing bells and you remember doing this in grade 10. I'm sure the people that are in grade 10 now remember this. And obviously we started the year with quadratic equations, so most of you should have revised this by now. So we've got 3b plus c is equal to 7, and I know that c is equal to 5 minus 2b. So the next part of this, we're going to substitute equation 1 into equation 2. So what that means is that wherever I see a c, I'm going to replace it with 5 minus 2b. So this is going to become 3b, which will stay the same, plus, in place of C now, I'm going to put 5 minus 2b. All right, and that's equal to 7. Okay, hopefully you guys are all following. 3b minus 2b, just simplifying, that's going to give me b. And then take the 5 over to the right-hand side. 7 minus 5 will give me 2. So therefore b is 2, but I still need to find the value of c. So I now need to take the value of b and substitute it back into equation 1. All right, so remember we've got from equation 1, we've got, let's just see where it is now, it's somewhere further up the page. We've got c is equal to 5 minus 2b. So I'm going to get c is equal to 5 minus 2, and now we know that b has a value of 2, so I'm going to put that in, and I get 5 minus 4, which is just 1. All right, so therefore, we've got b is equal to 2, c is equal to 1. So our equation is now going to become Tn. Remember, a was also equal to 1. So Tn is n squared plus bn. So it's going to be plus 2n and plus c, which was 5 minus 4, which is just going to give us an answer of 1. So we've got n squared plus 2n plus 1. All right, guys, I'm just quickly having a look here to see if this makes sense and that I've substituted everything correctly. We've got term 2 is 9 and term 3 is 16. All right, and we end up with Tn is equal to n squared plus 2n plus 1. All right, now that is your general term for this equation. As I said before, there are other ways that you can do this. There are other methods that you can use. I do know that. So if you know those other methods and you are comfortable with those methods, then please use that method. I always say to my pupils, use the method that you find easiest to understand and that you know you're never going to get wrong, which is why I always, by default, go back to showing everyone simultaneous equations to find the values of B and C in quadratic sequences, because I know it's the one thing that most people don't forget how to do, simultaneous equations. All right, but as I say, if you know another method, feel free, do it that way. Indy, do we have any questions? Is everyone following? Everyone still okay?
Yes, we actually do. Malebu is asking, do you get a mark for showing how you get your second difference?
Do you get a mark? Well, if the question says work out the general term, in this case, like it did, then you'll have to get a mark, because remember, your second difference helps you to find A. So that's where your mark will come in. So you're not going to get a mark just for showing that, okay, the second difference is 2. Maybe if your teacher's being generous and you're getting part marks in that, they might give you a mark for it, or half a mark. But really, you need that second difference in order to find the value of A. So that's where your mark will be allocated. Anything else?
And then we have Fumelani, he's asking, the process of using simultaneous equations is complicated. Can't you find the general term using other solution?
Yes, that's exactly what I've been saying the whole time, Luni, is that if there is another method that you know, please feel free to use it. I know that there are lots of different ways to find A, B, and C in quadratic sequences. So whatever method you feel comfortable with. Yes, simultaneous equations is a very long method, but it's full proof. And I don't want to confuse people out there, and I want to use a method that everyone's going to understand. So I'm not going to show you all those various other methods, because it can be confusing. In certain cases, you've got to remember, for example, the second difference is 3a plus b, and that's the second term in the second difference, and all sorts of confusing things for people who are just really struggling with the basics. So that's who I'm focusing on, the guys who are struggling with the basics. Okay, anything else?
Okay, one more question, I think.
Okay, Rochelle has also asked, she asked, do we always divide by 2 at all times?
For?
I think she was referring to one of the previous questions.
All right, the only time we divide by 2, Rochelle, is when you're trying to find A. You say that A is equal to the second difference divided by 2. That's standard. You always do it that way. I'm not sure if that's the question you had, but yes, when we're finding A, we say second difference divided by 2. That stays the same all the time. All right, so guys, we're going to carry on now with another example. And this comes from Clever Keeping Maths Simple, grade 11 learner's book, page 75, exercise 2.3, number 18. Okay, first question. Determine the next 2 terms of the sequence. All right, and the sequence they've given us is just a list of numbers. We don't know if it's quadratic. How do we determine if it's quadratic? Hopefully I've drilled it into everyone's head so many times now that it's just become, oh, what a boring question. It's quadratic if you have a constant second difference. Okay, so if you've got your list of numbers, you want to tell if it's quadratic, we need to find the second difference. And then once we know it's quadratic, then we can find the next 2 terms. Okay, so let's get going. So we say -1 minus -4. Guys, when you do this, be careful. I'm just going to do it on the side here. Just remember with your signs, you've got to be careful. It's -1 minus -4. Use brackets so that you don't confuse your signs here. So it's going to become -1 plus 4, which is just going to give us 3. Okay, so my first term of my first difference is 3. Then I'm going to say 4 minus -1. Again, be careful with your signs. It's going to become 4 plus 1, which is 5. And then we say 11 minus 4, and that gives me 7. Okay, so that's my line of first differences. I want the next row to be my constant second difference. So I say 5 minus 3, I get 2. 7 minus 5, I get 2. Now, you guys would have noticed in both the first examples we've done, the constant second difference happens to be 2. That's not always the case. Just so happens in these examples that we've chosen that your second difference happens to be 2. Okay, so don't think that that second difference is always going to be 2. It doesn't work like that. It depends on the terms you're given. All right, so here we've got our constant second difference of 2. Okay, because we have a constant second difference, that tells us that it is quadratic. All right, so how do I get the next 2 terms in this sequence? Okay, it's a little bit tricky. We've got to work backwards here, or forwards, depending on which way you're looking at it. Okay, so I want to know what this is. I want to know what that is. We don't have the formula. So how do we do it? Well, we can say we know that there's a constant second difference of 2. So the next term in the first difference must be 9. How did I get that? Well, 7 plus 2 gives me 9. And then the next term in the first difference must be 9 plus 2, which is 11. Because remember here, you've got a constant second difference going all the way of 2. So although I don't know what these are, all I've got to do is just add. Because I know my constant difference is 2, so I say 7 plus 2, I get 9. 9 plus 2, I get 11. If I wanted the next term in the first difference, I'd say 11 plus 2, but we don't need it. Okay, guys, remember, these are not your terms in the sequence. This is your terms in your first difference. Okay, we still need to find out what is the value of term 5 and term 6. Okay, now have a look at how these other terms that were given were worked out. In order to get 4, which is my third term, I went -1 plus 5. -1 plus 5 gave me 4. When I went to term 4, which is 11, in order to get there, I would have had to say 4 plus 7, and that gives me 11. So if I want term 5, I'm going to say 11, which is term 4, plus my first difference, which is 9, and that's going to give me 20. Okay, so that's term 5. Okay, so to get term 5, you simply say term 4 plus your term in your first difference. So we said term 4 plus the fourth term in my first difference, and that was 9, and I get 20. Okay, so term 6 is going to be similar. All right, we know that this term, term 5, is now 20. I want to find out what the next one is going to be. So remember, I said 11 plus 9 gives me 20. The next term, term 6, is going to be 20 plus 11. And that's going to give us 31. All right, so here we had to say term 5 plus the fifth term in the first difference. Okay, so guys, with this it can be quite tricky. Now imagine if you were asked to find the 20th term and you've just got this sequence of numbers. Very tough to keep on doing, okay, find the first term or find the term in the first difference, then add it to the term before. It can get quite confusing and sometimes you can forget what you've done and that kind of thing. So we need to be able to find the general term, because remember, once you have the general term, then you can work out any term in the sequence. We don't have to go back and now add and add and add and all of that. Okay, so we need a foolproof method, which means the next part of the question is very important. Find the general term of the sequence. Okay, and we're going to have a look at that after we get back from this ad break. We're going to look at how we can find a general term that will help us to find any term in the sequence so that we don't have to go through this process of adding the term before to the position in the first difference, and it gets all confusing and everyone throws their hands up. We need to find the general term.
And we all start crying.
All right, guys, we're going to go for a quick ad break. Before we go, I'd just like to read Ria 22. She says, or he says, at Learn Extra, I'm really enjoying the number patterns. Plus, we're currently busy with it at school. I'm learning a lot. This is so fun. So I'm just enjoying reading all your tweets, guys. Thank you very much for tweeting us. But do remember to tweet us before the show ends, and we'll keep reading your tweets. Thank you very much to Macmillan for sponsoring the show, and we will be back right after the break, guys. So don't you go anywhere. Welcome back from the break, guys. I hope you're refreshed and you got something to drink and you're back glued on your screen watching this show. We just have a quick question for Natasha. Ntavela is asking, my teacher taught us that C is the value of the number before term 1. Is it correct?
Yes, that is true. C is equal to term 0. But guys, this is what I was telling you during the previous example I worked out. It is a different method from the one we're using here, which is using simultaneous equations. So you can use C is equal to term 0. Perfectly correct, but it is a different method to simultaneous equations. All right, so without further ado, I'm going to get stuck straight into the example because it is quite a long one. All right, so guys, when we left off, what we were doing is we were going to look for the general term of this sequence, -4, -1, 4, and 11. We saw that it was quadratic. We saw that the constant difference in this case was 2. Remember, the constant difference tells us that it is quadratic. Okay. And we worked out that, well, I worked out during the break that your A, remember A is your second difference divided by 2. That is always the case. In this case, we got our second difference is 2. So 2 divided by 2 is 1. So therefore, my equation now becomes wherever there is, in the first case, we've got Tn is equal to n squared plus bn plus c. How did I get that? All I simply did was I replaced the a with 1. Okay, so it just becomes n squared plus bn plus c. Now, when we do the simultaneous equations, we've got to use terms that are in the sequence to help us find b and c. So I knew that term 1 is minus 4. So therefore, in place of n, I put in 1. And I say term 1 is equal to minus 4. And this will give me one equation that I can use to solve simultaneously for b and c. All right, so this is going to become 1 plus b plus c is minus 4. Therefore, b plus c is minus 5. And b is equal to minus 5 minus c, which we call equation 1. Then we're going to use the fact that term 2 is equal to minus 1 to give us the second equation. So wherever there is an n, I'm going to put in 2. Okay, so I'm going to get 2 squared plus b times 2 plus c is equal to minus 1. Okay, so this is going to become 4 plus 2b plus c is equal to minus 1. Therefore, 2b plus c is equal to minus 5. All right, we can then call this equation 2. Remember, we're using the method of substitution with simultaneous equation. So therefore, if b is equal to minus 5 minus c from equation 1, I'm going to substitute equation 1 into equation 2. All right, what that means is where there's a b, I put in minus 5 minus c. So it's 2 times minus 5 minus c plus c is equal to minus 5. All right, so then I'm going to times the 2 in, so I get minus 10 minus 2c plus c is equal to minus 5. Minus 2c plus c is just negative c. And negative 5 plus 10 is going to give me plus 5. So therefore, c dividing both sides by negative 1. So we're going to get c is equal to negative 5. All right, but remember, we're not done because we still need the value of b. And we know that b is equal to minus 5 minus c. This was equation 1, remember? So therefore, if I want the value of b, I simply substitute the value of c into equation 1. And I get b is equal to minus 5 plus 5, which is 0. So my equation now becomes Tn is equal to n squared plus 0n minus 5. But guys, we don't ever write 0n like that, do we? No, because that whole term is just going to cancel out to give us 0. So my equation is actually n squared minus 5. Okay, so that is the general term. Sorry, not your equation. Your general term is n squared minus 5. Now you can use that to find any term in the sequence. And in fact, what you should do is once you've got the general term, just check and see if it works. Okay, so for example, we know that term 1 was minus 4. If I put 1 in place of n, I'm going to get 1 squared minus 5, which is negative 4. So therefore it works. Term 1 is negative 4. You can go on and check with term 2, term 3, and so on until you're completely satisfied that that is the general term. But what you need to do in a test or an exam or anything like that, always just check at least one of your terms. Okay. Before I go into the next example, I'm going to quickly have a look over with our social media team and see if you guys have any comments for me.
Natasha, also I just want to say something quick. A lot of this stuff is practice, hey? So what they should do is, if they're not getting it and they're not getting it, guys, practice makes perfect, especially with maths and especially with what we're going over, right?
Absolutely, and especially with, remember this section is actually a continuation from last week. So some of you who might not have tuned in last week might be a little bit lost today because you didn't get the first part of it. So what you need to do is just go over your schoolwork, go over the notes that we have given you and that kind of thing, and just make sure, as Indy says, just practice until you get perfect. Okay. All right, so we're going to have a look at another question. And what I'm going to do is, in fact, I'm going to skip over this one and go to the very end because I know we're running out of time. And I want to do one where I've already worked out the solution. Okay, very, very common, guys. You will often get a diagram. And this just throws people off. They get a diagram and they think, oh, well, hold on, this is not maths. What's happening? There's pictures. It's just exactly the same thing that you've learned so far. You can only apply what you know, and we're not going to throw something at you that you haven't learned. So what you've got to do is, if you're given a diagram in a quadratic sequence, turn the pattern into numbers. Okay, it makes sense when you turn it into numbers. So let's have a look at this question. All right, as I said, I skipped over a question and I'm going straight to question 3. And we've got a little pattern here of diamonds. And they say diamonds are arranged in the following pattern, and they want you to determine the number of diamonds in the nth pattern and so on. Okay, first thing we need to do is we need to figure out what the pattern is. So, as I said, turn it into numbers so that it makes sense. In the first pattern we have 2 diamonds, 1, 2. Count the next one, you're going to have 2, 4, 6 diamonds. Next one, 2, 3, 6, 8, you're going to have 14 diamonds. Okay, so you'll just count all these little specks up and see what you get. And then we count the fourth pattern and there are 26 diamonds. Okay, this we can deal with. 2, 6, 14, 26. It looks like it could be some sort of pattern. Remember, the question says determine the number of diamonds in the nth pattern. So what are they asking you to find? They're asking you to find n. Okay, now if you want to work out the number of diamonds in the nth pattern, which means you've got to find n, that means you need to find a general term. Because remember, you can't just work out the number of diamonds in the nth pattern if you don't have a general term to work with. So we take the numbers that we now have, 2, 6, 14, and 26, and we're going to check and see if this follows a quadratic number pattern. So as I said, I've worked out the solution for you already, so we can just go over it. All right, so we've got 2, 6, 14, 26. To work out the first difference, all we do, we say 6 minus 2, that gives me 4. 14 minus 6, that gives me 8. 26 minus 14, that gives me 12. I then work out the difference between the terms in the first difference. So 8 minus 4 is 4, 12 minus 8 is 4. So therefore we have a constant second difference, and what does this tell us? The sequence is quadratic. Okay, once we know what type of sequence we are dealing with, we know what the general term is going to be. We know that we're dealing with Tn is equal to an squared plus bn plus c. All right, and remember we are solving for the number of terms. Okay, so what we need to do is we first need to work out the general term. Okay, so we've got a, remember, is your constant difference divided by 2. So a is going to be 4 divided by 2, which is 2. We plug that value of 2 in place of a. So the formula becomes Tn is equal to 2n squared plus bn plus c. We once again use simultaneous equations. Term 1 is equal to 2. That gives me equation 1 of b is equal to negative c. Term 2 is equal to 6. That gives me equation 2. 2b plus c is equal to negative 2. We then do all of our simultaneous equations, which means we need to substitute 1 into 2, substitute our values in, and we get c is equal to 2, b is equal to negative 2. Therefore, our general term now becomes 2n squared minus 2n plus 2. All right. Therefore, that will help us to determine the number of diamonds in the nth pattern. Now remember, that means find the number of diamonds in any position in that sequence of diamonds. Okay, so that helps us to find the number of diamonds in the nth pattern, in the 6th pattern, in the 7th, whatever the case is. Okay, so n, remember, is just a placeholder. Okay. So now that you've got your general term, you would be able to do the rest of this question, and I think we have provided that for you in your notes, so have a look, and you try this at home and see if you can finish it off. All right, and thank you so much for joining us, guys. That's the end of the number pattern section for grade 11. Cheers.
Thank you so much,
Well,
Natasha.
over to Indy.
Over to Looney.
All right. Thank you very much, guys, for tuning in. As Natasha said, that is the end of the number patterns lesson. And don't forget, guys, to go check out our lessons on learnextralive.co.za/live. And thank you very much to Macmillan for sponsoring the show. And guys, we will see you again next time, same place, guys. Next week, Monday, as it is a Maths Monday. Grade 11s, all the best for the rest of the week. And thank you very much for joining us.